Hey guys, Paul McWhorter here in El Dorado High School, and today we're going to be talking about square roots. Okay, we're going to be talking about square roots. So, first of all, what is the symbol for a square root? Yeah, it's the radical symbol. It's like that. Okay, what we know is that the square root is the second root, and so there's a 2 there. But if it's a square root, if there's a 2, we just don't write the 2, and we just write the symbol, okay? So we're going to talk a little bit about how square roots work and what they are. And so let's say that I had y is equal to x squared. When you see that, what should everyone scream? That is a what?
Quadratic.
It's a quadratic, right? And so we could sort of graph that out. We've been working a lot with quadratics. Okay, 0, it would be what? At x equals 0, it's 0. 1 is, minus 1 is 1. 2 is 4. 1, 2, 3, 4. And minus 2 is 4. And so the quadratic looks like that. It makes a parabola, right? So we've done a lot with that, and you understand that, okay? Well, let's say that you wanted to find the inverse. What is the inverse function of y equal x squared? Remember, how do we find an inverse? What do we do?
Place x and y.
Okay, we trade x and y. So x is equal to y squared. And then I solve for what? Okay, so I'm just going to switch places. We say y squared is equal to x. And then what can I do to both sides? The square root. So this would be y is equal to, and when I take the square root of x, I always put in a what?
Plus or minus.
Plus or minus the square root of x. Okay? So this is what? The inverse function of the quadratic. Okay, and we've got the square root there. Okay, so now let's look at this. If I'm at 0, if x is 0, where is y? 0. If x is 1, where is y?
1.
Or, yeah, plus or minus 1, like that. And let's see, I'm going to go all the way out to 4. At 4, it's where?
Plus or minus 2.
Plus or minus 2. Okay, so this is plus or minus the square root of x. Okay, so what could somebody say if you looked at this? What is the square root function compared to the quadratic?
It's turned on its side.
It's turned on its side, that's right. Okay.
Reflected over the y equals x.
Reflected over y equal x. So if I put in this y equal x, we can see that the square root is the quadratic reflected over y equal x. Does that make sense? Okay, so you see we kind of worked that out. And Logan, you probably were thinking about this from yesterday, right, about the definition of an inverse function. But do you see a square root is not mysterious, it's just a quadratic laid over on its side. Now what is true is a lot of times you'll just say more like y is equal to the square root of x without having the plus or minus. And in that case, let's go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, like that. 0 is going to be what?
0.
Okay, 1 is going to be what?
1.
Then we could go 1, 2, 3, 4 is,
2.
and then 16 is what?
4.
So you see how it's like kind of really flat, kind of laid over like that? And so the square root looks like kind of a really flat function, but what you can see is it's just the quadratic laid over on its side. And if you don't do the plus or minus, you just end up with one leg of it. Does that make sense? Okay, so let's look. How would we graph a square root function? Okay, what's really important on graphing a square root function is knowing where to start. So in understanding or graphing a square root, you know, number one is you better what? Find the domain. Okay, Because if I said like the square root of x minus 5, can I have x equal 2? What would happen if x equaled 2?
2 minus 5 3.
I'd have the square root of negative 3, and so I would get a not real solution, right? So I got to stay within the domain. So number 1 is find the domain. Okay, how would I find the domain of x minus 5? Okay.
X minus 5 equals 0.
Okay, no, almost, right. But what can I not have under a radical?
A variable.
And negative.
Oh, a negative.
I cannot have a negative under the radical. So that means what's under the radical needs to be what or what compared to 0?
Greater than or
Or equal to?
Greater than or equal to. Can I have a 0 under a radical?
No.
Can I?
Oh, yes.
Yeah. I can't have a 0 in the denominator, but I can have a 0 in the radical. So the domain is what is allowed. If negative is not allowed, then what is allowed? Positive or 0. Okay. So how would I find the domain? Well, what's under the radical? X minus 5 needs to be what?
greater than or equal to 0.
So x needs to be greater than or equal to?
Positive 5.
Okay, this is the domain. So if I'm going to graph this, and I'm going to create a table, x and y, where do I need to start?
5.
At 5, okay? And at 5, y is
0.
0. And then 6 would be a good one. It's 6,
1.
1. And then I think I want to go up like 4, so I would say 9. Was that right? No, what would I do? I want to go to 4, so I go to where?
10.
No.
9 minus 5 is 4.
Okay, I want 4. Yeah, 9. Okay. And this would be what?
4.
This would be 2.
Oh,
Right.
5 minus 5 is
Does that make sense?
4. Yeah, I just
Okay.
wasn't thinking about
9 minus 5 is 4. Square root of 4 is 2. Right. So what do I have? 1, 2, 3, 4, 5. So that is 0. And then at 6, I'm at 1. And at 7, 8, 9, I'm at 2. Okay, so I have this. That problem is easy if you what?
Make the 2.
If you start by figuring out where the domain is, right? But if I just said, well, I think I'll start at 12, and then you graph something just like this, that's going to be wrong because you've got to show it coming down to the axis. So you've got to plot it over its domain. Does that make sense? Okay, let's do another one. What if I ask you to graph y is equal to the square root of 3x plus 4? Okay, Jaden, what's the first thing that I should do?
You should see if it can work. Oh, find the domain.
Find the domain, okay. I should find the domain. So how am I going to find the domain? What would I write down?
Whatever's in the radical.
Whatever is under the radical needs to be what?
Greater than or equal to 0.
Greater than or equal to 0. And so what is under the radical, Mario?
3x.
3x plus 4. Now what do I do, Braden?
You move 4 to the other side.
3x needs to be greater than or equal to?
Negative 4.
So x needs to be greater than or equal to?
Negative 3/4.
-3/4. So, now when I make my table, what is my first x value? What should it be?
It'd be 4/3.
Ah.
Oh, sorry, I was.
Oh, who told me wrong? And I didn't even pay attention. -4/3, okay? So what's the first value I should use?
Negative
-4/3. -4/3 times 3 is? -4 plus 4 is? Square root of 0 is? 0. Okay. Now what I would probably like to do is, what would be another good one? What if I did -1? Okay. -1 times 3 is? -3 plus 4 is? 1 square root of 1 is 1. Okay. How about if I did 0? 0 times 3 is 0. Plus 4 is 4. Square root of 4 is 2. Okay. And then I think I could do 4 is another good one. 4 times 3 is
12.
12 plus 4 is
16.
square root of 16 is. Okay. So you see, what would I do here to graph it? I would come to, this is minus 1, and then 1, 2, 3, 4. So this is minus 4/3, and I'll go 1, 2, 3, 4. Minus 4/3 is 0, like right there. Minus 1 is 1, so I'm starting up. 0 is 2, and then 4 out here is 4. Okay, so it's going to look like that. Does that make sense? Do you understand why you have to start with the domain?
Yes, sir.
Okay, you got to start with the domain. All right, I'm going to show you one other thing on this lesson, and that is we can also do inequalities. And inequalities are just the same, but you need to also shade, okay? And you still start with number 1, always find the domain. So let's say that y is less than the square root of 2x minus 6. Josie, what is the first thing that I should do? Find the domain. So what do I write down here, Josie?
The parentheses
Uh-huh.
greater than or equal to 0.
And then what goes in the parentheses?
2x minus 6.
2x minus 6. And then therefore 2x needs to be greater than or equal to?
6.
6. X needs to be greater than or equal to?
3.
3. Okay. So now I have my what? Domain. X and y. So what x should I start at? 3. And when I'm at 3, what is y? 0. What would be another good one to do? Like, you guys think, what would be a good one to do next?
4.
8 minus 6 would be 2. Square root of 2 is kind of hard. How about 7 halves? If I do 7 halves, 7 halves times 2 is 7. Minus 6 is, square root of 1 is. Do you see how you want to kind of pick values that'll give you perfect squares? Okay. What would be the next one? Like, what would be a good one? Like, wouldn't it be good to have 4 under here? If I wanted 4 under here, what would x need to be?
10.
No,
So it need to be 5.
it'd need to be 5. So if I had 5, then 5 times 2 is 10.
So you
10
need
minus 6 is 4. Square root of 4 is?
2.
Okay. So let's look at that. So we're going to graph that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Okay. So if I'm at 3, I'm where? 0. And then 7 halves is like 3 1/2. I'm where? At 1. Does that make sense? And then at 5, 1, 2, 3, 4, 5, I'm where? At 2. So it's like this, right? Now, am I done? No. Okay. First of all, tell me one mistake I've already made. Yes.
It's a solid line.
It should be a dotted line because it's less than that, right? Well, not a dotted, it should be a dotted curve, right? Because it's less than that. If it was less than or equal to, it would be solid. Okay. Now, do I shade above it or below it? Below it. So I would shade it like that.
You shade it to the line.
Yeah, you can just shade it to the line. Okay. But for your answer to be right, you've got to have what? The domain. You have to come all the way back to the right spot on the domain. Okay. Homework is Chapter 7, Section 3, 9 through 12. I'll write these down. Algebra 2, 9 through 12, 24 through 26. The bonus is 34, and this is 7-3. Okay, that's it.